Good morning, students. Our today's topic in the subject of physics is practical applications of static electricity. In the topic of static electricity, so concentrate yourself. We are going to start. First, practical application of static electricity which we are going to read is an electrostatic precipitator. Coal burning power stations produce huge amount of the smoke pollution. This smoke is a cloud of small dust particles or ash. It can be removed by using static electricity. Some thin wires are stretched across the center of the chimney. So, across the center of the chimney, some wires are stretched. These wires are charged positively to about 50,000 volt and then cause the gas around them to get to charged or ionized. Because of this, the smoke particles become positively charged. So when the smoke particles passes through the chimney, they get charged, positively charged. These positive particles are then repelled by the wires towards the earthed metal plates where the dust sticks. A mechanical hammer hits the plates every few minutes and ash fall down into the bin. So, into the chimney, some wires are stretched and get a voltage of around 50,000 volt. This creates a condition of ionization. So, the gas around it gets ionized and the dust particles which passes through the chimney gets positively charged. The plates repel them towards the earthed metal plates. To the metal plate, the dust particles stuck, and there is a mechanical hammer which hit the metallic plate at regular intervals, and the dust particles fall into the dustbin which lie just at the bottom of the metal plate. So this is a good way of removing dust particles or the dust from the chimney. Later, it is used to make house bricks. So this is even useful that dust which is collected in the dustbin is used to make house bricks. So here is a video of the electrostatic precipitator. So look now, these dust particles are entering into the chimney, the plates, and these dust particles will stuck to the plates which is earthed, and there is a hammer that will struck on the plates and dust particles will be collected in the bin which will be later used in making of the bricks. Next practical application of the electrostatic electricity is in operating theaters. In operating theaters, gases used to anesthetize patients are easily flammable. Static charges produced due to movement of the blankets or clothes can cause spark, and this spark may cause explosion. As a precaution, anesthetic machines, trolleys, and patients are linked to the ground by metal chains. In addition, doctors and nurses wear anti-static conducting shoes. So these are the precautions due to which spark can be prevented. So this is the technique which is used in operating theaters. Next, practical application of the electrostatic electricity is fingerprints. A similar method can be used to show up fingerprints on paper. The paper is placed near a charged wire like one of the plates in the chimney, and a fine black powder is used instead of the smoke. So same technique which is used in the chimney is used for fingerprints. The powder sticks to the fingerprints but not to the clear paper. So whenever we put a thumb or fingerprint on a paper, the powder will stick to the fingerprints, not of the clear part of the paper. So this is the technique which is used in making the fingerprints. Photocopiers are based on similar method. So look at the application of the photocopier.
Geography is based on the principle that a certain material can.
So look now, here is the original paper. Here is the lens that will take the picture of the original paper, of the image that is printed on the original paper. Here is a toner, and when this image will be taken on this thing, the powder will stick only to the image but not of the clear part of the paper. So in this way, the printout will be taken.
Retain an electrostatic imprint of a brightly lit image. When a document is placed in a copier, a bright light is bounced off the paper, through a lens, and onto a
Here is a lens.
drum.
So look
The
now.
coating becomes electrostatically charged with a mirror image of the document. As the drum rotates, the fine black particles that make up the ink, called toner, are attracted to the charged areas on the drum, the same areas that would be the print on the paper. As copy paper is rolled over the drum, a heat roller fuses the toner from the drum and onto the.
So this is the technique which is used in photocopier machines. Here is another practical application of the electrostatic electricity. Bicycle and cars are painted using an electrostatic paint spray. The nozzle is given a charge and this makes a better spray. The droplets all have the same charge and repel each other so that the paint spreads out to form a large even cloud. Less paint is needed because the charged droplets are all attracted to the object, even the back of it, because it has an opposite charge. So the same technique is used here. The nozzle of the spray machine is given a charge of positive, so the paint droplets get positively charged. Because of the same charge, they repel each other, and when they are dropped onto the object to be painted, so the droplets repel each other and make a even film, even layer onto the object. Because object and paint are oppositely charged, so they attract each other even to the back of the object as well. So this is the technique, and in this technique, because the object and paint attract each other and paint droplets repel each other to make a even layer on the object, so less paint is used. So this is the technique which is used in paint spraying. And here is a video for you people to understand this technique.
I'm going to try painting your bike. It can be a really messy job, especially if you use wet spray paint. It's hard to get a good even finish. Rachel's painted her bike with powder using static electricity.
So look now, an even layer of the paint is there on the object because because the paint and the object are oppositely charged, so they attract each other. So a very nice uniform layer of the paint is there.
Powder paint rubs against the sides of the gun barrel as it comes out and gets positively charged. Because the powder is charged, it gets attracted to nearby objects.
So look now, the droplets are positively charged.
It even goes back on the gun, but most of it goes where it's needed, on the bike. So painting's a far less messy job. turn your strike around to bend the back, but Rachel doesn't bother. Her defense gets attracted around the back anyway.
So look now, even the back side of the object is also painted. So this is the technique which is used in spray painting. The same idea is used to make crop spraying more efficient for farmers, because in old times a lot of the spray was used for spraying on the crops, and the bigger problem was at the bottom of the leaves there were insects. The spray was it was difficult for the farmer to spray on the bottom of the leaves. So the same technique which is used in spray painting is used. Same technique is used in the spray painting in on the crops as well. So the nozzle of the spray painting is get charged positively, so the droplets of the spray get positively charged, and the crop is oppositely charged, so the spray and the object, that is crop, is attracted to each other. And because the droplets of the spray are positively charged, so they repel each other, and there creates a uniform layer of the spray on the whole of the crops. And even the backside of the object also attract the spray towards it because of the oppositely charge. So this is the technique which is even more helpful in the modern world. Less time is used for killing the insects, and less spray is used as well. So look, here is our video.
For many, many years, there were no real choices in spraying technology. A solution emitted from a conventional hydraulic sprayer covers only the top or front of the object, but leaves much of the target uncoated, especially on the back or underneath side. Electrostatic spraying systems has changed that. Now you can coat the entire targeted object. Watch this apple duster demonstration and see for yourself. The first apple will be sprayed with a conventional spray technique without an electrostatic
So this technique is without electricity.
charge. Now we apply the electrostatic charge to the sprayer and coat the second apple.
And this technique is with electrostatic charge. So the spray is attracted even to the back side of the object as well, and a uniform layer is created on the object. So this is without, and this is with.
Whether spraying for insect,
Next, we are going to read another practical application of the electrostatic charge, that is preventing fires. A liquid flowing through a pipe can become charged in the same way as two objects rubbed together. This can be dangerous if it causes a spark and the liquid is inflammable. In case of the oil tankers, etc., this can be dangerous because if a spark is there, so explosion can take place. For this reason, whenever an aeroplane is being refueled by a tanker lorry, they are always connected together by a copper wire. So this is the technique. Electric charges accumulate on an aircraft during the flight and on trucks transporting flammable liquids. Some preventive steps may be taken to avoid such hazards. In the case of the aircraft, the tires are made of the slightly conductive rubber, so that the large amount of the charge built up on the body of the aircraft during flight can be discharged harmlessly during the touchdown. So This is the technique which is used in the aeroplanes. For the same reason, spare petrol for cars should always be carried in metal cans because because plastic cans can be ionized, a spark can be there, and explosion can take place. So spare petrol should be taken or should be stored in metal cans. Large ships have been known to explode because their tanks were being cleaned out by a high-speed water jet which became charged and caused a spark. Nowadays, the tanks are filled with an inert gas before cleaning starts. Walking on nylon carpets can give you a shock when you touch the door handle or a radiator. A spark can generate, and this can give you a shock. Modern carpets can be made conducting to prevent this. High voltage generators. The Van de Graaff generators is a very useful static charge generator. It can produce potential difference or voltage of up to 14 million volts. It is used in nuclear research to accelerate subatomic particles. Okay, some hazards of the electrostatic. Electric shock. If your body provides a path for a large current to flow through, enabling a charged object to discharge, you will get an electric shock. So if the path is created between you and a charged object, you will get the shock. Electronic equipment. Electronic equipment such as computer boards and hard drives can easily be damaged by electrostatic discharge. To protect them from the electrostatic discharge, the equipment is usually packaged in an anti-static packaging material so that the thing does not create a path between a charged body and to the earth, because if the path is created, this equipment can be damaged. So that's why the packaging material which is of anti-static packaging is used. These materials usually have a thin layer of the metallized film. The conducting film act as an electrostatic shield for the components placed inside. Lightning. Lightning is an electric discharge from a cloud to the ground, so same technique is used. So because the clouds are charged bodies, so if a person or a building creates the path, so the damage can be done from a cloud to the ground. The base of the cloud is usually negatively charged. When a cloud passes over a tall building, the top of the building becomes positively charged by induction. Because of the separation of the charges, the positive charges come on the top of the building because of the attraction of the negatively charged part of the cloud, and the insulation of the air may break down and lightning results. This explains why it is very dangerous to swim in the open sea, play in an open field, or hide under a tree during a thunderstorm. If you are caught in thunderstorm in the open, the best thing to do is to crouch near the ground. So this is the best way to avoid the lightning. Soldiers building trenches on mountain tops must never use zinc sheets as a form of the shelter during thunderstorm because they can create the path between the charged object and the earth. To prevent lightning from the damaging tall building, lightning conductors shown below in figure are used. When a negatively charged cloud passes overhead, it induces a positive charge on the point at the top of the lightning conductor. The point then repel positive ions to the cloud to neutralize it, so that it is less likely to produce a lightning flash. The electrons that are attracted to the conductor travel down into the earth, and electric current flows through the wire. So look now, here is the process. And here is the video that will make it more clear to you
Negative
people.
charges at the bottom of the cloud causing
So when a cloud passes over a tall building or over the tall tree, the negative charges accumulates on the bottom of the cloud that actually attracts the positive charges placed on the positive charges on the object which is placed on the earth. So because of this, a path is created. So look now, how can we avoid it?
lightning to strike the ground. The negatively charged particles group together and seek out positive charges from the ground. The excess electrons inside the cloud create a channel of charged air called a leader that reaches down looking for positive charges.
So some leader charges come down from the cloud to look for the positive charges on the objects which are on the earth, and if they are met with positive charges, they will create a path, and then light will be passed from cloud into the object.
The leaders attract other channels of charged air created by protons on the ground. These charged ground-based channels are called streamers. When the stepped leader from the cloud meets a streamer from the ground, a conductive path is created. An electrical current called the return stroke travels from the ground to the thundercloud. This return stroke releases tremendous energy, bright light, and produces thunder. Thunder is the sound that follows a flash of lightning and is caused by sudden expansion of the air in the path of the electrical discharge. A lightning discharge.
So this was the lecture, students, a very important one. So read this lecture again, understand it, learn it, and make your notes. Thank you so much.